And greetings, boys and girls. Why not put an automatic weapon, very precise, precision automatic weapon, linked to a computer and a sensor so that you can program it like you do your phone? And whether this robotic assassin is in a vehicle or an airplane or on a train, once programmed and activated by hitting a button, the thing will find the target and either obliterate the target or damage the target. Suppose we put this robotic shooting machine on board a train to test it, and we put targets alongside the train track to put the train in motion to test just how well this robotic machine, robotic assassin, would perform. And so you put up a silhouette of a deer, and your machine spots the target, hits the deer in the shoulder with one shot. But suppose you made a mistake and the machine thought the deer was real and the deer didn't fall. So the next time it encountered the target, a silhouette of a deer, it unleashed a short burst, 10 quickly spaced bullets at the deer and put a row of bullets across this silhouette of the deer, the target. Okay, and so part of the test involved accelerating the train faster and faster to see when and how your robotic assassin would fail. And suppose the outcome of your test is that the machine doesn't know the difference between a target, a silhouette, and the real thing. And when the target doesn't appear to be destroyed, it remains standing, the machine becomes more determined. And it activates a second robotic machine in a different part of the train. And so as you approach the next target, 2 guns open fire, each with 10 shots at the silhouette of the deer. But as they did so, as they began to open fire, the train passed a large mound of earth, a hill, a grassy knoll, a mound of earth, so that, and this, the width of this mound of earth was approximately the same width as the space between these 2 shooters. And your machine calculated what to do in this case and fired 10 shots from each weapon as though the hill wasn't there. The machine really didn't care. 10 bullet holes, 5 from either end of the train as it passes behind the hill, the mound of dirt. 5 from each gun. If this train was simply reflecting sunlight instead of bullets, and instead of a silhouette of a deer, you had an old-fashioned photographic plate, what do you call it, that is exposed in the camera whenever the shutter opens. Old-fashioned camera such as what they had back in, say, 1920, with a relatively speaking, slow shutter speed that stayed open for maybe a half a second. So a moving object, like a speeding train, would probably produce multiple images, a fuzz, a blur on this old-fashioned photographic plate when it was developed. And the blur would appear to be longer than the length of the train, and the distance between the shooters on this train would appear to be stretched. And it would record the shots from either robotic assassin, 5 from each shot, because they're fired in a sequence, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, real fast. And but one sequence of shots, but the train is moving, and so it produces a line of bullet holes, a line of photons on the photographic plate, producing the blur, producing the illusion that the train lengthened with speed. But it's only an illusion. And I suppose that this type of erroneous thinking led Albert Einstein to assume that things in motion get longer, and if they get longer, they must get denser, and as they travel faster and faster and faster, how fast? Well, as they travel very fast. And how fast? Well, if they approach the speed of light, oh, that's pretty fast. The speed of light is gosh awful fast, and we ain't never gonna get that fast. But an object, according to Einstein, in motion near the speed of light would experience time dilation, he called it time dilation, which he means to express time contraction. Relatively speaking, from an observer, from a stationary observer, time would appear to slow down. Oh yeah? How do you explain that? How do you explain time would appear to slow down to the observer? Whereas the observer's time would be normal. And the clock, if there was a clock on this moving object, would appear normal to anyone observing the clock, say, on board this fast train. But from an observer, but see, ain't no observer gonna see any clock inside a train moving near the speed of light. So this is all a mental exercise. It's a what if.